Welcome to my channel, The Sake of Physics. In today's video, I'm going to discuss what is a position vector, and I will solve a problem related with that. So it basically describes the location of a point with respect to the origin, and usually it is represented by R position vector and drawn by a straight line such that its tail coincides with the origin and head with point P, where P has paired points A and B. So the projections of position vector R on the x and y axes are the coordinates A and B, and they are known as rectangular components of the vector R. So as we know that the rectangular components are basically the projections of a vector along x-axis and y-axis. So here if I would like to write down vector R in terms of A and B, then A is along x-axis, so I will be the unit vector for the A, and for B I can write down J unit vector because it is along y-axis. So this is for the two dimensions. If the R vector is in three dimensions, for example x, y, and z, and this is origin O, and R is somewhere in three dimensions, and A, B, C are the rectangular components along x, y, and z axis, then we can write down position vector in terms of their components like this. So AI plus BJ plus CK, where K is the unit vector along the z-axis. So here I would like to discuss an example. So in the figure you can see two vectors are given, A and B are, we can say that OA is one vector, position vector, and OB is another position vector. So here the positions of two airplanes at instant are represented by 2 points A and B from an origin O, and this distance is in kilometers as shown in figure. So the first part of the question is what are the position vectors, and second part is calculate the distance between the two planes, which is AB. So here if I write down position vector in general form, so AI plus BJ plus CK. So this is the general form. So position vector for first aeroplane A. For aeroplane A, the position vector is OA, which is given by the points 2I plus 3J plus 4K. And for the aeroplane B, I can write down OB equals 5I plus 6J plus 7K. So this is the first part of the question, that what are the position vectors. So for the second part, we need to find out what is AB, the magnitude, the distance between both aeroplanes. So here if we use the head to tail rule, you can see that we can write down the resultant vector OB equals OA plus AB, and because AB is unknown, so AB will become OB minus OA. So these are all in vectors form until now, but we need to find out the magnitude. So AB in vector form will become, by plugging the values from part A, OB was 5I plus 6J plus 7K, minus 2i plus 3j plus 4k. So here I can write down 3i plus 3j due to this negative sign plus 3k. So the magnitude will become 3 square plus 3 square plus 3 square, because the magnitude along x, y and z, they are all 3. So this will be square root of 27, and these are all in kilometers. Or I can write down it's almost 5.2. After rounding off, I get AP equals 5.2 kilometers. So this was the simple example for the position vector. How can we write down the position vectors and how can we find out the magnitude? Thank you so much for watching.